Hi guys, this video is going to be on our first activity. So if you haven't done so already, go to our beach board content section in week 1. You'll scroll down to assignments and assessments, and then you'll want to upload or download activity 1 instructions, the answer sheet, as well as the data. Okay, so we'll go through this I guess activity, it's like a subheading, I guess. So we'll go through this by sheets within the big data sheet, and I'll have shortcuts on the video so that if you don't want to do the entire activity all at once, you can pick up at different points in the video pretty easily. Okay, but basically what you're going to have is your activity instructions. This will tell you primarily what you're going to be doing in the actual activity. Okay, and then your answer sheet is where you're going to record all of your answers. This is the document that when you're done, you'll upload to Dropbox so that it can be graded. The format of this document should either be as a Word document, or if you convert it to a PDF, that is also acceptable. Okay, so you'll be filling this information in as you go. The purpose of these activity videos is to guide you through different methods on how to run tests, on how to make calculations, when and why we make calculations. So really, other than kind of like little housekeeping type tasks, such as making sure like your graphs are labeled correctly, etc., you really should never, and like critical thinking questions, you really shouldn't ever do bad on activities. Okay, so our first spreadsheet is called Swim Team Fitness, and this is kind of the processes that we'll use when we have a rank order distribution. And usually I have a goal, right? So how you create a rank order distribution based on a certain set of criteria, okay, or based on the criteria of what the rank is. And usually we use this for small groups of people, just because it's a little bit more manageable when we're working in Excel. So the scenario that goes along with this data set is you have a swim team whose members participated in various fitness tests, and you'll see in the data sheet those are pull-ups, plank time, and push-ups, and the number of pull-ups and push-ups are recorded, as well as the time in seconds they were able to hold their planks. Okay, and the basic skills that we're working on in this data set is sorting, and this will come in handy the entire semester. So understanding how to apply filters and how to sort your data is really, really important, especially if you have a big data sheet and you're trying to find certain pieces of information. It's a lot easier if you can sort it, and then you kind of know where to look based on the sorting criteria you have set. So the procedure, or what you're trying to accomplish with this, is to put the members of the swim team in order from least to greatest based on the number of pull-ups they were able to perform. Okay, so the way that we're going to apply filters first, there's a couple of different ways you can do this, and I'll show you both ways. Before you apply the filter, you have to indicate what columns you want filtered. So usually if you have some type of heading row, that's where I usually highlight. And then what you can do from here, usually if I expand this, okay, all the way, there should be on this home tab, right, there should be a sort and filter function over here. You can either click on the filter button and then pick the way that you want to filter information there. Usually if you just click filter, you'll notice these little arrows pop up on the side. Okay, so that's one way to apply a filter to your data. I'm going to undo that and then show you the other way you can apply the filter. So again, you highlight your headings row, and then you can go to data, and then you have filter options in this tab as well. So let's say in either method we applied a filter. Now, when you actually want to make any changes to your filter settings, you want to make sure that you're clicked within the data range at which the filters have been applied. If you click out here and you're like, I want to sort something, it'll give you an error message saying that you aren't in the selected filter range. Okay, so make sure you're inside. Doesn't matter, any one of these cells would work. Okay, so there's a couple of ways that we can sort. You'll notice there's an A to Z and a Z to A. So these are descending and ascending orders, respectively. Okay, so if we were working, say, with names and we wanted to apply an ascending filter to everybody who's actually in this, set of data, we could say ascending, and then you'll notice that everyone is now organized by their first name, or the letter of their first name, right? If we want to do descending, now we go from X to A. So in letter respect, that one's pretty intuitive. Okay, if you want to go by number, say that we're sorting by pull-ups, okay, ascending would basically be 0 to whatever, okay, and then descending would be the reverse order. You will notice that when I changed the filter on the pull-ups column, however, that the name column reverted back to its original state. Okay, so you can do easy, fairly easy sorting by working with the arrows. However, I personally like to go off of a custom sort. So again, if we look at our instructions, we're supposed to rank people least to greatest based on the number of pull-ups they were able to perform. So we've done that using our, arrow ascending function, right? However, you'll notice that some people were able to perform the same number of pull-ups, okay? And this can be a problem, especially if you're using a rank distribution, okay, or a rank order distribution, because sometimes there needs to be an extra set of criteria to identify the actual order that people end up going into. So we can put sort, okay, and this is like our custom sort function. So we could say, I first want to sort people by the number of pull-ups they can do. Say we're ranking people based on their arm strength, right? So pull-ups would probably be the first evaluation that we're going off of, right? And then let's say push-ups is the next best assessment of arm strength, okay? This is all hypothetical for the example, okay? In this first sort function, we're saying we want to sort by pull-ups, going from smallest to largest, okay? We can add additional criteria by pressing this add button, okay? If you're working off of a Windows operating system, there should be an option similar that would say add criteria or add. Somewhere it should say add, okay? So you first sort by pull-ups, then we could sort by push-ups, again saying smallest to largest. And so take note here, currently we have Lauren and Irene just as an example. They have the same number of pull-ups that they've accomplished. Lauren has recorded 39 push-ups where Irene has recorded 25. Okay, so if we press OK, you'll notice that these two ladies are then reordered such that the person who did the least amount of push-ups is ordered prior to the person who did the most amount of push-ups, even though they have the same number of pull-ups listed. Okay, so being able to apply multiple filters can be really helpful, right? The other thing you can think about is if you don't want your filters anymore, you can always turn them off using that function. Okay, if I undo this, you can also press the clear button, and that will clear any existing filtering that you've got in this data range. So if we go back to custom sort, we can always, reapply that, and then we're good to go. Okay, so on your answer sheet, what you are addressing based off of this information is what is the range for the number of pull-ups completed. Okay, so this is going to be asking for what's the minimum number of pull-ups all the way to the maximum number of pull-ups. Using this rank order distribution, you're also going to note how many people were able to complete exactly 15 pull-ups. And then for part C, using the first letter of each name when the members are in rank order, smallest to largest, first based on number of pull-ups, then based on number of push-ups, you're going to write the sentence that is spelled out by the bolded letters. Okay, so that pretty much concludes our first spreadsheet in this data set. Okay. Next, we'll go into our multi-sport pull-up survey. Okay, and this is going to be an example of data for when we're working with a simple frequency distribution. Okay, usually we use simple frequency distributions when we have a large amount of discrete data. Okay, discrete data is basically whole numbers or non-rational numbers. Okay, such that, like, if we were counting how many children does somebody have, you can only have whole numbers of children, right? You're not going to have 2.5 kids because anatomically it just doesn't really make sense, okay? So large amounts of discrete data in whole numbers. Making a simple frequency distribution is really helpful when we create histograms or bar graphs to indicate the frequency at specific data scores. Okay, so the scenario for this spreadsheet is that we have members from various sport teams who were tested on how many pull-ups they could do. Okay, so as you can see on this spreadsheet, we have the different sport teams and then their respective recorded numbers of pull-ups. Each row represents, or each score represents, a different person, assuming that each athlete is not part of another sport. Okay. We're going to be introduced to a couple of functions or skills that will be helpful for you to use in Excel for the rest of the semester. Okay, so functions are always started by putting an equal sign, and then you put in the respective function and then the criteria that that function demands in order for it to calculate. We're also going to go over freezing cells and the method in which how we freeze cells. This will be really important from here on out when you're organizing data. Cell references are really handy when you're trying to mass produce calculations and you want to be able to copy a given function or calculation into another cell such that it applies to data that you want it to. That way you're not having to put in formulas for every single calculation you want to make. This will make more sense once we actually get into everything. And then we're also going to learn how to create a bar graph and manipulate the chart elements within that bar graph for this particular spreadsheet. So the first thing we want to do with this is to create a simple frequency distribution using the data provided. And then we're going to create a bar graph to represent that frequency distribution. Okay. So what we want to do first is make a frequency distribution, right? So we're combining everyone's data all together and we want to know, let's say we'll call this column number of pull-ups. Okay. And some cool tricks that I'll introduce you guys as we go through these. One is if you want to auto adjust a column. So you can see a number of pull-ups. This is in column I and it's kind of running into column J. If you hover your icon or your mouse right across the columns, if it turns into an arrow, that gives you the ability to highlight the entire column. Okay. If you go right in between the columns that you're interested in, specifically to the right side of the column, this is going to be your adjustment tool for column I. Okay, so if we double click when we get this icon with the two arrows on the sides, it'll auto adjust to the width of whatever's the longest width that is required for the cells in that column. Okay, and you can do this, if I undo that, you can do it with that column highlighted or not. Okay, so if we have a number of pull-ups, and then we want to know at what frequency those pull-ups show up out of all of these different sports. Okay, the first thing we need to know when we're making this frequency distribution is the minimum number, because that's going to be the starting number here. And then the maximum number will be the ending number at the bottom of the frequency distribution. Okay, so a simple way that we can find this information is by putting in a minimum function, right? So we could say equals minimum, and you'll notice there's like a list of functions that will pop up. Min is the minimum function. I didn't mean to double click on that cell there. Okay, and then you'll notice it says like number 1, number 2, etc. This is the criteria that is required of you to add into the actual function. Basically, number 1 just means some range of data that has numerical values in it. Okay, so you'll notice if you click on any one cell, right, this blue highlight here will indicate where that cell is located. Right, columns are indicated by letters and rows are indicated by numbers. We want to find the minimum in this entire cell range. So if you just click and drag, right, you'll be able to highlight the desired section that you want to highlight. You then press enter and we get that the minimum value is 3. You can see how this function would be helpful if you have a really large data set. Instead of having to go through every single row to find the minimum value, we found it pretty easily just using a function. Okay, now we also need to know where to stop our frequency distribution as far as the number of pull-ups that were achieved by people. And we can do this by finding the maximum. So if we put equals max, right, you'll notice the function is there. We again highlight the range of cells that we want to find our maximum in, and we press enter. Okay, we now know that our maximum is 20, so that's where this number of pull-ups column is going to end. Now, a cool thing that Excel does is it can auto number for you. All you have to do is put in a desired numerical pattern and it should auto-generate numbers. Okay, the way that you will copy a pattern is by hovering over this little green square at the bottom right of the cell. Okay, and you'll notice the icon when you hover over that, the icon changes from a white plus sign to a black plus sign. When it is black, it is in copy mode. Okay, so as I drag downwards, this is the first example of copying. Okay, and you'll notice it like auto numbers and then just keeps copying the same number. Okay, so whenever you want to copy something, generally, this is not necessarily the best example because what I'm copying here is actually this formula bar. Okay, so this is actually, I'm glad I kind of did it this way, but you'll notice in this first row we have the value 3, which is our actual minimum. When I dragged that function downwards, you notice the cell reference area drags down one row. Okay, so basically what you do whenever you are creating an auto-numbered list. If you want it numbered, you have to make sure that you're not copying functions along with your numerical pattern that you're trying to set. So what I'm going to do is, we know the minimum is 3, we know the maximum is 20, so we know our stopping and starting points. So I'm just going to put 3 in this box, okay? And then as I start to drag, this is one copying setting which I was trying to simulate in the first time, okay? If you don't indicate a numerical pattern, all Excel is going to recognize is that you want to copy whatever's in this first cell, okay, or whatever's in the cell that you're copying from. So in order to make an automatic numbered list, you have to identify some sort of pattern. So I want to count by whole numbers, right? So I want to go 3 and then 4 so that we can identify how many people within these 4 sports were able to accomplish that number of pull-ups, okay? So once I've identified the difference between scores, which is 1, I can highlight these 2 cells, and then again I want to do a copy function, and you'll notice there is a number that pops up next to that plus sign as I drag, and you'll notice it keeps changing by a unit of 1, which is what I want. So I'll drag all the way until I get to 20. Okay, minimum number of pull-ups that were achieved, maximum number of pull-ups that were achieved. That's why I stopped there. Okay, now the frequency part, you could go through this entire data set and count, like, okay, only one person got a 3, then go to the next one, and then count how many 4s you find, and then how many 5s you find, etc. Okay, that would be super time consuming if we had a large data set. So the way around this is we use a COUNTIF function. Basically what the COUNTIF function does is it counts the number of cells that meet a criteria that you insert. So if we do equals count, and you'll notice there are actually quite a few count functions, but we want COUNTIF, okay? You put a parentheses to start indicating where you want Excel to make the calculation you're looking for. So first we have range indicated, so we would just want to look in this entire range of cells, okay? And then our criteria should match the value in our number of pull-ups section, okay? I'm a big fan of using cell references, okay, because when you copy this, the reference will shift as you want it to, okay? So I'm going to show you an example. If I just put 3 in here and we put enter, I get what I want when I copy and paste, right, into this box. But when I drag down to 4, right, first of all, we have this issue, which we will address in a second, but it's still thinking that my criteria is 3, okay, that I want to count all of the cells or the number of cells that meet or have 3 in them as a value, okay? So if you did it this way, you would have to change, right, the number every single time, and that's quite honestly a waste of your time, okay? So instead of putting the actual value you're looking for, do a cell reference, okay? And so that way you can see this will change. We now have 3 people who meet. If we double click on this cell, you can see who's actually in the function, okay? So we notice that our new cell reference for our criteria actually meets the number of pull-ups we're trying to find the frequency for, okay? Now, an additional problem that we notice is the range does not actually match the entire data set. So this is an important thing to remember when you're copying functions, is that when you copy downwards, whatever your cell references are will shift down the number of rows at which you're copying. So let's say we copy this function one more time, right? You'll notice when we start with this first reference, right, everything is beautiful. And then when we go down to cell 4, right, this entire range, the size didn't change, but it dropped down 1 row. Similarly, if we look at the next frequency count for 5 pull-ups, we shifted down yet another row. This isn't what we want, okay? So I'm going to show you how to change it. Let me delete these numbers first. So this is where freezing comes into play. And I've included the freezing rules over here, okay, where you want to freeze rows versus freeze columns. Now remember, your rows are indicated by numbers. Your columns are indicated by letters. So what you're desiring to freeze is kind of indicative on where you put your dollar sign. Okay, the dollar sign is how you actually freeze stuff. So in this case, we notice when we copy downwards that the rows are changing. So we want the row reference to stay the same. Okay, since all we're doing is going downwards. So if we click into our original function that we're going to be copying, all we have to do, remember, rows are indicative by numbers, so we just put the dollar sign in front of the number that we want to freeze, right? If we're freezing an entire range, you have to apply this to the whole range. So we want to freeze C5 to F24, okay? And that will just set anytime we copy this function downwards, this blue box, the area that it encompasses will not change, okay? So we can test it out by going to our function box that we're originating in, right? And then we can click the blue plus sign, and let's just copy it down to number of pull-ups at 4, right? Just to make sure that it worked. Again, you can double check the contents of your function by double clicking on your cell you're working out of. So you'll notice now that we have fixed our problem where this blue box shifted down 1 row because we freezed this reference area. However, this red box is still shifting down appropriately like we want it to because we did not freeze that area. This will make a lot more sense as you keep going through this activity because I built it in such a way that you would have to practice this. Okay, so there's a couple of ways that you can continue copying this function all the way down to 20. The first way is how I'm doing now. When you get that black plus sign, you just click and drag all the way down, and then you will have values automatically pop up, right, based on the function that you put in and the cell references that each of those has for that particular function. I'm going to undo this. The other way that you can copy, right, is if you hover with the black plus sign and you double click that box, it'll automatically sense where numbers have stopped, right, in an adjacent column, and it'll auto stop itself from reproducing that calculation all the way down, okay? So we now have a simple frequency distribution. Should look familiar to what you saw in the lecture, right? So we have general ordered of whatever we're measuring, and then we have how many times that value shows up in a particular data set. Okay, so how is this useful? One, we can get a general idea of where people are, right? We're not actually doing any mathematical calculations. Really, it just kind of lets us see how the data is spread out. Okay, so we'll see in future weeks how frequency distributions can help contribute to looking at the shape of a distribution, right? And we can do this through a couple of different ways. One is histograms, and the other way is bar graphs. We're going to do a bar graph for this particular example. Okay, so what I want you guys to do is you're going to highlight the frequency column only. Okay, you're going to the Insert tab, and then this is your chart area. Okay, we have bar charts, we have scatter plots, you can make a pie chart, histogram, okay, or these are line graphs actually, sorry, these are scatter plots. Okay, so you have a whole bunch of different options on what types of graphs you can make. In this particular example, we're going to make a bar graph, and just use the first example. We're not going to get fancy with any 3D stuff because that's like just too much for this class. Okay, so we now have a frequency distribution. Let me slide this over. Okay, indicating, right, our first frequency is 1. Perfect. Next frequency is 3, and then 4, and then 6. Okay, so the actual height of our bars should correspond with the values that are in this chart, or in this table here. Now, the part that you have to be wary of when making simple frequency distribution bar graphs is the x-axis. Okay, so the first thing we're gonna do is make sure that this actually matches what we're counting. So actually, first what we're gonna do is add in our axes labels so that it's a little bit clearer why we're changing the numbers. Okay, so the way that you can get to this, if you're working in Windows, there should be a green plus sign on the outside, and that is basically a shortcut to chart design, okay, which should be an added tab when you actually click on the graph. Okay, if you click outside of the graph, you'll notice chart design is no longer an option. So you have to actually be clicked on the graph to add any chart elements. If you're working with a Mac or any other processing system, usually you're going to want to go to chart design and then add chart element. Okay, so we go to the drop down menu and we can add axes titles. So we add a primary horizontal axis title and we'll add a primary vertical axis title. These are two standard things you should have on every single graph that you submit in this class. Okay, the horizontal axis, right, if we have an indication of number of pull-ups, right, or this is like basically corresponding with the frequency column, okay, if we have a frequency of 1, right, this x-axis point should actually be how many pull-ups a person has achieved. So this bottom axis is going to be number of pull-ups. Okay. And then, as we just discussed, the y-axis is indicating the actual frequency. Okay. So we know the x-axis is number of pull-ups. Therefore, the first value that's listed here should not be 1, right? Because our actual number of pull-ups values, our minimum starts at 3. So this is how we are going to amend the x-axis. Okay. If you choose any chart element, right, we can click around here and you notice that different numbers will highlight. We want to change the x-axis, right? So if you just double click on that x-axis area, should pop up as format axis. You'll click on axis options, okay, and it usually will give you information on numbers. In this case, it's not because it didn't recognize two sets of information coming in. So just for reference, if you wanted to change these values, if you double click on those axes, you should be able to. And that should actually, we might be able to do that in a different data set. So for this example, actually, we're just going to click on the graph, and then we're going to go to select data. Again, this is going to be in the chart design area. The other way you can find select data is if you two-finger click or right-click in the chart, and it should be an option. Okay, this is one thing that I hate that is different between Mac and Windows, is that this whole setup is very much not the same. In Windows, you should have two columns. One is for the horizontal axis, one should be for the vertical axis. You're going to be amending horizontal axis labels, so just make sure that you're looking at that particular icon. And there should be an option for you to edit or select what your labels are going to be. So if you're on a Mac, this is where we're going to work, okay? If you click on this icon, it's basically going to give you a selection option, and you'll see there's a little green shadow box that's following my cursor, okay? Basically, all we want to say is that we want our horizontal axis labels to match this set of information, okay? So you watch this graph as I press enter and reset my axis labels. You'll notice that everything down at the bottom should reset to what we actually want it labeled as, okay? The last thing to change on this is our chart title. Usually, for the graphs that we'll make in this class, we don't really need to be super specific. So you can just call the title whatever the name of the spreadsheet is. So in this case, we'll just call this one multi-sport pull-ups frequency distribution. Sure. Okay. As long as you have some type of title indicating what it's like, what the graph actually is showing, or what spreadsheet it goes to, you should be fine. Okay. Please now, after you finish your graph, okay, you can copy it either by pressing Command or Control C. Command if you're on Mac, Control if you're on Windows. Okay. And then you'll switch, whoops, wrong button. You'll switch to your answer sheet and then paste your graph into your answer sheet. Okay, like so. Just make sure when you paste that numbers are legible. Okay, make sure that things don't get cut off or you have ... stuff going on. So just make sure it's as clean as possible. Within Word, you should be able to adjust your graphs however you like. Okay, usually I just do a standard copy paste and just leave it at that. Okay. That's the only graph you need for this particular one, but that is how we make said bar graph for a simple frequency distribution. Okay. Hopefully that made sense. We're now going to do spreadsheet number 3, which is looking at running relay times. So I'm going to click on that one. Okay. And just for reference for your answer sheet, this one's pretty self-explanatory as far as the questions you're being asked. Okay. So indicating what the minimum number is, maximum number, those are two things that you had to calculate, right? Number of pull-ups that had the highest frequency, as well as which values or which number of pull-up values, right, were achieved by exactly 4 people. So on that one, you're just going to look at the frequency column, find the value 4, and then match that up to the values for how many pull-ups were achieved, okay, by only 4 people. So hopefully that part makes sense. But now we're going to running relay times, okay? So let's, I'm going to minimize that one. And we've got our data, okay? Relays are, well, we have this organized by place and then the time that it took the person to run the relay, okay? So this is going to be a good example for a grouped frequency distribution, which is when we have some range of data to expressed as criteria for a given group, right? Because if we did a frequency distribution for each of these times, it's not necessarily going to be helpful for us when we do further statistical calculations. Okay, so grouped frequency distribution or distributions are good when we have continuous data, otherwise known as rational data, that has it's not confined to whole numbers, right? So this scenario we have running times were collected for relay teams, right? And the times are listed as hours, minutes, and seconds. So they're running long relays, similar to marathons, okay? And so that's how the format is. Like this would be 1 hour, 33 minutes, and 6 seconds, okay? In this particular spreadsheet, we're going to create a grouped frequency distribution to count how many teams finished in 5-minute intervals, okay? We're going to first start at 1 hour, 30 minutes, and then stop at 3 hours and 10 minutes, okay? So the way that we're going to start this is we're going to have the lower bound of the interval. Okay, so this is per the instructions. Table should have 3 columns: lower bound, upper bound, and the frequency. Okay, lower bound of the interval, upper bound, and frequency. Okay, again, the lower bound is going to be the lower end of the interval, so we're starting at 1 hour, 30 minutes. Okay, so if you put 1:30:00, it should stay in that format. Hopefully, we're gonna pray that everything works out here. Okay, 5 minutes from there would be 1 hour, 35 minutes, and 0 seconds. Okay, now this is where it gets fun. We need to create intervals all the way down to get to, where is it? 3 hours and 10 minutes. Okay, so basically we want to create a number pattern that says, right, every 5 minutes. So this is going to be 1 hour 40. Okay, and if everything works out super smoothly, if we highlight these two, we should be able to drag till we get to 3 hours and 10 minutes. Okay, and 3 hours and 10 minutes, sorry, that was a crazy scroll, was chosen because that's the maximum number, right, or nearest 5-minute interval that matches the maximum time that was recorded. Okay, so we now have a numbered list, right, indicated by intervals. Now some of you might be thinking ahead and you're like, but wait, an upper bound is also included in the lower bound of the next group. This is a great question and we're going to address it in a second, okay? Because technically, what we could say is that the upper bound of this is 1 hour, 34 minutes, and 59 seconds, but that would get really annoying to have to type out, and it's easier if we do it this way, trust me, okay? Just know we're going to address it, okay? Just bear with me, okay? So the frequency that we're going to calculate is now going to still be addressed when in this time column, okay? And we want to find all the values that are between these two numbers. Between meaning including the lower bound and excluding what's actually in the upper bound value. So we want anything that's greater than or equal to the lower bound but less than the upper bound. That is how we address the issue of not counting. Say somebody, a relay team ran 1 hour and 35 minutes exactly. That is the way we avoid counting them twice. Okay? So in the frequency column, remember, in a simple frequency distribution, we only have one number for a number reference. So instead, in a group frequency, we now have 2 references, okay, or 2 sets of criteria that we're trying to match. So we're going to be using a count-ifs function instead, right? Count if you have 1 criteria, count ifs if you have multiple criteria. So the general layout of the actual function is going to be the same, right? So we're going to do count ifs with an S, put a parentheses, and you'll see criteria range, criteria ... okay? Criteria range is just the data you're working with. Okay, so this will be all of our values in column B. Woohoo! Okay, and then you put a comma, and then you insert what the criteria is. So this is where it gets fun. our criteria is that we want all of the values, right, for the lower bound that are greater than or equal to the lower bound. Okay, so the way that we notate this is we indicated the range, okay, and then we have to put quotation marks, okay, and we put greater than, equal to, so that's kind of like our criteria, and we want that greater than or equal to match a cell reference of 1 hour and 30 minutes. This is fun, okay? Now, we put another comma, because that's our first set of criteria. Okay, so this is now, you can see bolded here is criteria range 2. Criteria range 2 is going to be exactly the same as criteria range 1, because we're still looking in the same set of data. So you could either re-highlight all of this, or we know the cell range is right here, so you can just type B2 to B187. Okay, you put a comma, and now we identify what the criteria is for range 2. Now we said we want everything greater than or equal to 1 hour 30, and we want everything less than, not including, right, 1 hour and 35 minutes. So we would put quotation marks again, we put less than, and we want that less than to match a cell reference of 1 hour and 35 minutes. Okay, you can close your parentheses to end the function, and you press enter. And look at that, we have a frequency of 2. Now if we look at our total times, we notice that there are indeed 2 values that land between 1 hour and 30 minutes and 1 hour and 35 minutes. Mind blown! Okay, now if you remember from the previous spreadsheet, we like things that are copyable. You will notice everything in this function is a cell reference area. It is thus copyable if we go downwards. However, you have to remember, when we double click this, you notice the cell reference will change row to row because we are copying downwards. Now, we want this to happen for the lower and upper bounds. We do not want this to happen for the actual range of data that we're working with. So, again, the way that we fix that is by adding $signs to freeze the row reference, which is the number. Okay, and we have to do this for both ranges. So we're going to freeze, right, by inserting $signs in front of the numbers of the range areas only. Leave the lower bound and upper bound references. That's the wonderful thing about Excel, unless you're colorblind. Okay, if you are colorblind, just kind of keep a mental note of where things are. But Excel color coordinates where the references are, so you can easily identify what you're actually changing. Okay, so we'll put our $signs in front of our range areas, and that should make it so that when we copy all the way down, right, it doesn't matter if, let's say I click on this one, right, my range is the same, or it's what I want it to be, this blue box, right, encompasses all of the data that we've collected for these relay teams. And then my reference, right, I want my values greater than or equal to the lower bound, but less than the upper bound. And magically, you have just deleted a whole bunch of work, right, just by creating a copyable function. So this whole concept in this first lab is applicable to the rest of the semester. Okay, so hopefully it helps kind of truncate the times that you're spending on organizing your data. Okay, but now we have created this lovely grouped frequency distribution table. Okay, and now what we want to do is create a bar graph using the 5-minute intervals from 1 hour 30 minutes to 3 hours and 5 minutes as the x-axis labels. Okay, so similar to how we did our simple frequency distribution, the first thing you're going to do is highlight the frequencies that you've calculated. You go to Insert, we go to Bar Graph. Okay, again, every time you insert a bar graph, or graph in general, my apologies, you should have your primary and vertical axis titles. Remember, if this doesn't automatically show up, if you have Windows, you click on the green plus sign at the top right corner of the chart after you've clicked on it, or you can go up to the top tab area and click on chart design. Okay. And then we need to label our axes. So this bottom axis is going to indicate the actual time. So we just put time, right? And then if you want to put the format, so hour, minutes, seconds, that's totally fine. If you don't want to add it, I'm not going to dock you points. Okay. Our vertical axis, similar to our simple frequency distribution that we created, is going to represent the frequency. Okay. And our chart title is just, we could put running relay times. Running relay times. If you want to add running relay times grouped frequency distribution, you could also do that as well. Okay. Something to indicate where it actually belongs. All right. And then you'll notice similar problem to our previous graph is that our horizontal axis is not labeled correctly. So if you remember, we can go to select data, or you can right click or two finger click to get select data. Either way works. Okay. And again, we want to change the horizontal axis labels. So I'm going to click on this, and I want my horizontal axis labels to match, right, this entire lower bound column, because that is what it indicated, 1 hour 30 to 3 hours and 5 minutes. Okay, so you press enter, press OK, and then you'll notice all of your horizontal axis labels change accordingly. Okay, so now similar to the last graph, what you would do is copy and paste this into your answer sheet. Okay. And then you're just going to answer these simple questions indicating how many teams finished within certain intervals. Okay. Make sure again that you're not double counting this upper bound, okay, by indicating you have a less than on that particular upper bound criteria, right? So hopefully this wasn't too overstimulating. I know this activity gives a lot of information, but it's really valuable information that you're just gonna be able to keep practicing as the semester goes forward. Okay. So that is it for our running relay times. We are now going to look at our swim meet data, and instead of bar graphs, we get to make scatter plots. Okay. So the goal for this particular spreadsheet is to understand how to create and manipulate data in scatter plots using some given data, which we've collected for multiple swimmers, right? And we have recorded their body mass, their height, and their 50-meter swim times. Okay, basically what we want to do within this data sheet is create scatter plots to organize the data such that body mass is the independent variable and swim time is the dependent variable. Now, if you remember from the lecture, independent variables are often also referred to as X variables, and your dependent variables are often referred to as Y variables. This is important because it tells you, right, based on how you insert your data, it tells you what's going to come out in the actual scatter plot that you input. Okay, and order matters for this. Okay, so whenever you highlight your data, the left column is going to represent the x-axis, the right column will automatically represent the y-axis. So if you have to shift some columns around, you do what you must. Okay. All right, so the first thing that we're going to do is create a scatter plot using body mass as the independent variable, which we want oriented left of our dependent variable, which is the 50-meter swim time. So if we look at how stuff is organized, these are actually backwards, right? So an easy way that we can do this is if we, actually we have two options, because the actual data itself isn't changing. What we can do is insert another column next to column B. So the way that inserting works is that if you click on the full column, right, so when you make your icon that black arrow, if you right click or two finger click on that column, you can insert. Whenever you insert something, it always goes to the left, right? If you're working with columns, if you're working with rows, just an example, if you insert, it always inserts above. Okay, so keep that in mind because you'll mess with spreadsheet data a lot, I guarantee. Okay, now that we've inserted this column, we know body mass needs to be on the left. So what we can do is simply copy this column here and then paste it over here. Okay, that way our data is organized so that we can add to the scatter plot. Okay, there are other ways of working with this, but I'm doing this for a specific reason. So just go with it for now. Okay, if we want to add a scatter plot, what I want you to start with is by copying your headings, so body mass and swim time. And then when you highlight cells, you can either click and drag all the way to the bottom. Personally, my preference, is to scroll to the bottom and then you press shift and hold it and then click on where you want to highlight. And that way, if you have like a really big spreadsheet, you're not like clicking and dragging forever and then you zoom past where you meant to go. So it's like a little bit less sensitive. So what you do is you highlight the section you want to graph. You go to insert and then scatter plots is where all the little dots are. So we're just going to put in a regular scatter plot and you should get something that looks like this. Okay, you'll notice that the graph tried to auto label. This obviously is not what we're looking for, but it kind of cuts our time down because this is body mass versus 50 meter swim time. So technically it helped. Okay, so that's our chart title covered. We do want to add our axes titles, which should be nothing new compared to when we put them on the bar graphs. Okay, so axis title, what should happen, and this is how you check your work, right, is that body mass should be the independent variable on the x-axis, which if we look at our units, right, body mass relatively between 64 and 76, right? So this we can call body mass, and that's in kilograms. Okay, and then our y-axis should represent relatively the values that we have for swim time. So we can call this 50 meter swim time in seconds. Okay, so we've got our axes labeled now, and we have our scatter plot. Now, this is what I was trying to show you before that didn't work out in my favor. If you double click on either one of these axes, right, let's say for some reason, I'll move this over real quick, that I wanted this to count by every unit, so I wanted it to read 64, 65, 66, right? You can see the minimum boundary is 64, the maximum boundary is 76. So if you wanted to readjust these values, you would always do it in the bounds area. When you look at the units, usually you'll only adjust the major unit. So instead of 2, if I wanted it as counted by 1, you can see this changes now. For this particular graph, you can just leave it at the default. That doesn't bother me at all. Okay, but the same thing goes for the y-axis. Let's say you didn't want things changing by 0.5, but wanted them changing by 1, right? You can always adjust as needed. And this is a very valuable tool if your scatter plots have a lot of data, say, over here, and there's like no data over here. And then it makes it so that your data is a little bit more spread out and easier on the eye to look at. Okay, but this is pretty much all we need to do for this one as far as creation goes. Okay, we then want to make a scatter plot using height as the independent variable and body mass as your dependent variable. So height being on the x-axis, body mass being on the y-axis. So if you're thinking about organization, right, and in your mind, you're like, all right, height is independent, that's on the x-axis, that means height needs to be to the left of body mass, right? And so then you look at your data, height is not to the left side of body mass, right? So this is where we can say, okay, I want to copy and paste body mass so that it's on the left side. Honestly, my biggest recommendation for this particular spreadsheet is that you copy and paste to reorganize. Don't cut and paste, because let's say that we took this column, and decided to paste it on the other side of height. This graph, you notice when we click on it, it's programmed to read these two columns. So if we take data out of column B, then we take data out of the graph. Okay, so that's why I said I was specifically doing things a certain way. So I would just recommend copying and pasting body mass on the other side of your height column, so that way you're organized the way you should be. Again, you're not actually changing the data, you're just moving it around. Okay, little redecoration. So same thing as last time, you highlight once they're in the appropriate order. You're going to highlight the data that's going into the graph. You press Insert, and we're doing another scatter plot. I'm going to get rid of this for a second and move this down here. Okay, and now we're working with body mass and height. So we can just label this height versus body mass, right? Similar to our first graph, we're going to add our axes titles. And this should feel a little bit more comfortable for you now. Okay. So on the x-axis, we should have height. On the y-axis, we should have body mass. Okay. And then this is a perfect example of what happens when your x-axis doesn't auto-made itself so that it reflects the data nicely like this top one. So if this happens, usually what you do is you say, all right, the data is pretty much between like 150 and 200. So if you double click, and if you want to add units to these, totally fine, body mass in kilograms, height in centimeters, okay? Not required, but optional if you want to add them. Just make sure there is a label there, okay? But if you want to adjust this, right, we double click on the horizontal axis. You should have a format axis box pop up in your toolbar to the right, and then you want to click on this bar graph here. That'll take you to your axis options, which is where your bounds will be, where your units will be. It's all great. Okay, so what we want to change is our lower bound to 150. We can keep the upper one at 200, right? But you can see when we do that, it'll auto adjust if it thinks 200 isn't a good number, and you can always change it back if you want to. But it just gives us a better idea of what the data actually looks like, not all scrunched up into a little tiny space. It also makes a better utilization of our graph space, right? If we were putting this into a publication, or if we were putting it on a poster for a poster presentation, it's a lot easier to look at and gives a better idea of what type of trend is happening, okay? So again, make sure data is accurately represented, your axes titles are on there, your chart title is good. You'll copy and paste both of these graphs into your answer sheet, which then you will also be having some critical thinking questions, right? So based on both of the graphs, you're going to address or note if there appears to be any relationship between the two variables that are given and why you think there might be a relationship or not. Okay? You want to be as descriptive as possible. Okay? Relationship is basically pointing to correlations, which I'm sure most of you have been exposed to at least once prior to this. I know anyone who's taken 312 knows what a correlation is because I used to teach those labs as a grad student. So see if there's any relationship, indicate what you think that relationship means, and then again, copy and paste your graphs down here. Okay. The last, just kidding, not the last one, we have lactate values now that we'll be addressing questions on. So let me come on up here. Okay, and then I'll switch to the correct spreadsheet. Okay, so for this one, we're getting a small introduction on how to calculate averages and standard deviations. We haven't conceptually talked about these yet, but I'm sure most of you know what an average and standard deviation are now. If not, you will know in a week or so. So don't sweat it. Okay, but this is just an example of how to create a bar graph with multiple series and or multiple groups, right? So if you're doing a study and like in this case, right, we have studying the effects of pedal rate on the physiological responses to HIIT training. So we've got different pedal rates, a low pedal rate, normal pedal rate, high pedal rate, and then we took lactate levels at resting, right, before they started the exercise, mid HIIT intervals, and then after they were done with the exercise. Okay, so all we want to do is create a table that is nicely organized such that we can make a bar graph to represent this data. We're going to start this with the resting lactate, average resting lactate levels in the low pedal rate. So again, anytime we want to insert a function, we're going to type equals. Average is easy to remember because that is the function name. Okay, that's what you're calculating. And then inside you're just going to put the range of data you're trying to calculate. So we want resting low PR. Right, so we're only going to highlight resting low PR values. Okay. And then we want the averages for resting normal PR values. Well, you'll notice that there's 9 people in each of these categories. So a fun thing that we can do is just copy and paste, right, these values here. But you'll notice, again, when we copy downwards, it'll move one row respectively to how many rows we're copying, right? So an easy way to move these boxes, if you hover over any of the borders, you should have a little hand. You can just click and drag that box, right? And it'll change the range of data that goes into your function, okay? The other thing we can do with this is copy sideways, right? So middle, okay, we copied across columns, therefore our references are going to go across columns, and this works just fine, right? Because it's mid-low PR, and that's where we are, okay? What you can do from here, since these ones are now formatted for these chunks of data, you can just copy those across as well. Okay, and that's always a good idea to double check, right? If I'm in this box, it's the average for post and high pedal rate, which we are post interval in the high pedal rate group. Okay, so that's an easy way to make sure your formatting is all fine and dandy. And then we're also going to calculate the standard deviation for each of these groups, as this will be important when we put in error bars. Again, if you've been in 312, you've made error bars before, but most people usually forget how to do it. So we'll go through it again. Okay. So to calculate standard deviation, you just put equals STDEV. There are a lot of variations on standard deviation, but honestly, this is all you need, okay? So same process, we're just going to copy, right? And then we can copy this downwards. Again, remember to change your cell range. That is very important, right? Because then you're reporting data that isn't actually true, which is not good, right? And then once we have all of these formatted to our respective groups, and we just want the data to hop over the references, quick copy paste, or like copy drag, easy peasy lemon squeezy. Now we are ready to make our graphs. So when you have multiple groups, usually you list those groups on like in a column, and then if you have any subsets or series, they'll be listed on top. And there are ways that you can flip-flop. So if you're doing research or you're trying to build some type of graph and it doesn't come out the way that you want it to, know that you can always readjust it after the graph has been made. So what we're really interested in is graphing the averages, right, of our lactate values for each of these groups at each of these different time periods. So we're just going to copy everything, right, including the labels and the numbers. And there's a really good reason why we do this. It's so that we don't have to go in and fix the labels ourselves later. Okay, so again, we're going to just do a regular bar graph, and you'll notice we get something that looks like this. Okay, so you can see what's listed across the top gives us our x-axis labels, and then as I said, your groups end up being groups or series. They're often interchangeable. Okay, so first things first, we need to make sure we have our axes titles, so horizontal and vertical. Okay, in this case, since we're saying resting, mid, and post, this axis would be representative of, you guessed it, the time period that we collected the data. And then what we're actually measuring, which is the dependent variable, right, would be our lactate levels. Okay, and you can just write lactate levels, that's totally fine. Super acceptable. Okay. Chart title, again, you can just label this wherever it's supposed to go in, like you can label it what the spreadsheet's name is, okay, since we're not using any of these for publishing, right? So basically that's it. Super easy, right? But it's a lot easier than starting from scratch where, you know, like if you didn't copy these guys, this would show up as Series 1, Series 2, Series 3, and adjusting those isn't that hard, but it's a lot more work, okay? So if we go to select data, I wanted to show you guys how we can flip this stuff. So the chart range is identified as this guy here, okay? And you'll notice our series are listed as the petal rate, so that's where we get different colors, okay? You'll also notice the horizontal axis labels, if I click on that, are what are in like the little dotted area, okay? So if for some reason you were like, no, I actually wanted my series, or you know, the everything by color to be by time period, and I wanted the bottom part to be organized by the petal rate, you can do a simple switch row column. Okay, and now your series are going to be your petal rates, and your horizontal axes labels would be your, these would be your time periods, and your horizontal axes labels would be your petal rates. So if we click that, right, we can easily change the graph. Just know your axes labels, or your axis title that you added personally would have to change, okay? But I want it the way that I have it here, so it's just a side note in case you ever get into that situation, okay? In addition to this graph, we want to add error bars. Wonderful, wonderful error bars. So the way that we get to error bars is first you want to click on the graph, and then you're going to add chart elements either through the Chart Design tab, or if you have a green plus sign and you're using Windows or Windows Processing, you'll go down to error bars and then click on more error bar options. Okay. From here, if you have multiple series, you'll be able to choose which series you want to generate your error bars for. So let's start with the low pedal rate. And then I'm going to shift this sideways so you guys can see a little bit better. Okay. If you take note of the error bars that are in place right now, it says both. Remember, standard deviation, it's always listed as the average plus or minus the standard deviation, meaning deviation could be above or below the mean, right? So this is default, right? And I mean, if you don't like having both, you can always do minus, where it will go downwards from the mean, or you can do plus, where it goes above the mean. I don't care which one you guys use. I'm going to stay on plus. I think that one looks a little bit cleaner. And then from there, you're going to go to custom. Okay, you'll go to specify value, and then it'll ask you for a positive error value. So if you click on your chart selection tool, all you're going to do is select the standard deviations that match up with your low pedal rate. So you click enter. We don't need to express a negative error value, or we shouldn't, because we are only representing the plus end. Okay. And then we are golden. Boom, bop, done. Okay. So then anywhere, if you notice, like when we were on these, right, there's little bubbles around the error bars that we're working on. Click anywhere in the chart to take those bubbles away. And then go to add chart element, and then we're going to do error bars for our normal pedal rate. Okay, if you don't unselect these error bars that have the bubbles around them, it'll just take you back to the adjustments for those error bars. So it's really important you click off of them. Again, I'm only going to do plus, but you can mess around if you want to do the other ones. If you did the other ones, let's say we did both, okay, just if you're, wondering. If you do both, you have to identify both the positive and the negative error value. The way that we would do that is the normal pedal rate standard deviation for the positive and the normal pedal rate standard deviation for the negative. Okay? If you don't do both, your error bars would be wrong. Okay? So if you're doing both and that's what you want to submit, totally fine. Just make sure you adjust it correctly. Okay. But I'm just going to keep mine on plus because I think it's prettier. Okay. Then, again, click anywhere but the error bars that were just highlighted. And then we're going to do error bars one last time for the high pedal rate. Okay. So again, you'll want to be in this 3-bar area. I'm going to change mine to plus, custom, positive error value should be on the high pedal rate. Okay. You press OK, and then we're all adjusted and ready to go. So you'll just copy and paste this graph into your answer sheet. Okay. And then you're just going to answer whatever calculations you ended up getting, right? You'll just put in those values as they're requested in these parts A and B. Okay? All right. The last, but definitely not the least, in value at least, is our heart rate spreadsheet, and this one's super fun. So let's say we use the same group of people, okay, but now we want to have a scatter plot graph, but for a lot of different time points at which we gathered heart rate. Same idea, like we have people doing different pedal rates, but instead of lactate values, we're collecting heart rate, right? 0 being at rest before they start, and then 20 seconds, or every 20 seconds after they start, woohoo, all the way up to 20 minutes, Okay, so this is a great example of a big spreadsheet, okay, or a lot of data. What we want to do is create a table and scatter plots that have multiple series, right, for low, normal, and high petal rates, but we want to be able to put it into a scatter plot format instead of a bar graph format, okay? So what you're going to do is, skip this, you can read that on your own. We want to find, or we want to normalize rather, people's heart rates based on their max heart rate, right? Because somebody who has like a heart rate of 140 versus 148, while these numbers are very close to each other, I mean, as percentages of their actual maximum heart rates, they're quite different, okay? So we're going to normalize everybody's data by taking the percentage of their heart rate max. So that's step one. And then we want to find the average heart rate or percent of heart rate max for each time point within each petal rate, and then create a scatter plot of those averages. Okay, so kind of a bit going on here. The first thing that I'm going to have you guys do is click on this top cell, press and hold Shift, and then click on the very last row that you're working with. And then don't press anything, but slide yourself all the way to the end, press and hold Shift, and then hold the last cell, right? All the way at the bottom of 20 minutes, okay? From here, you're just going to copy that data, so Control C or Command C, and then we're going to paste it, okay? That way, all of our titles are already set up. And then heart rate max can stay, but all of these time points here on out, you're just going to delete. Okay, so get rid of them. All right. From here, we're going to create calculations. Okay, so if we want a percentage of heart rate max, right, you take percent usually is over of, right? What is the actual heart rate that was measured over the heart rate max, right? So essentially we're asking what is 124, or what percent is 124 of 190, right? So we're going to try to make a copyable function. So you're just going to put equals. And then we want to know 124 divided by 190. Okay, and for us, let's multiply this by 100 so we get a nice number that looks like that. Okay, now from here, we want to copy this across this row, right? Because we want to calculate the heart rate max for this individual person using this cell reference for every single time point. Okay, we know if I drag this right to the right, we're copying by columns, right, or by shifting columns. So if I copy this over, all of my cell references shift one column over. So if I double click on this, you'll notice the cell reference is not where I want it to be. I actually want my cell reference to be on the heart rate max, right? So this tells us that if we're building a function that's supposed to be copyable, as we drag it across columns, we need to freeze the column reference for this heart rate max, right? We've frozen row references before. Now we want to freeze column references, which means instead of putting the $ in front of the row reference, which is the number, we want to put the $ in front of the column reference, which is the letter. Okay, so if I press enter here, okay, this one we don't, oh sorry, wrong one. Put it in front of C, my bad. The red box, we want to freeze this box. We want this box to move over, so don't add any $ to the D part, okay? So you press enter, and then we check to see if this copying worked, right? So double click on that 73, and you'll notice cell reference changed to the 20-second time point, but our heart rate max reference is still where we want it to be. So this is great. We can just slide this, copy it all the way down to 20 minutes. Okay? From here, we want we want all of these functions to copy downwards, and I don't know where this ends, so this is going to be fun. Oh my god, that was a by chance situation. I copied exactly to where it was supposed to stop. I'm so impressed with myself. Okay, so you're just going to copy this downwards. Now the reason we're not starting by copying down and then across is it's a lot messier. Okay, you of course can do it that way, but if we set it up where we freeze our cell references by columns first, when we know as we're copying by rows, we want our references to shift downward for both the heart rate max reference as well as time points, okay? Because it's representative of each different subject. So that's why I did it the way that I did. If you wanted to do it a different way, totally an option, but it's a little bit harder, okay? So now we've converted all of our values to percent of heart rate max, okay? And now we need to calculate the averages of this percent or these percent heart rate max for each of our pedal rates. So you're going to copy these time points. Those are going to serve as your headings, okay? And then we're going to have a low pedal rate, normal pedal rate, I can't spell, normal pedal rate, and we're going to have a high pedal rate, okay? From here, we're calculating the average, right? And low PR at 0, okay? So low PR at 0. Boom shakalaka. You press enter, and we have calculated gold, okay? Same thing. I want the average for the normal pedal rate at 0. Okay, and you can do the same process that we did before on the previous spreadsheet where you copy, right? And then you just drag the reference box. Whatever way resonates with you, do it, okay? You have unlimited time on your exams, so I want you to do something that you remember rather than trying to always get the fastest way to do things. Obviously, being able to do things faster will take a huge chunk of time out of what you're doing, but whatever way works for you, okay? From here, now that we have our chunks set up for our time points, all we have to do is copy and drag all the way to 20 minutes, and we have our averages calculated for our time points, okay? Now we're ready to make our scatter plot. So again, similar to the last spreadsheet, right? You want to highlight your labels, both that are going to be in your series or make up your series as well as make up your horizontal axis. So I'm going to do the shift hold method, okay? And then now I have all of my data highlighted that I want to graph. I go to insert and I go to scatter plot. And look, I have a scatter plot. What? Okay. Like all of our other graphs, you're going to add your axes titles. Okay, so my bottom area, which we will adjust because, no we won't. It did it the way I wanted it to. Never mind, we're good. Okay, this is going to be our time. Okay, and then our vertical axis title should be our heart rate. Or actually, we'll type it percent heart rate max, okay? Because that's what it actually is. All right, from here, similar to when we did the body mass versus height, or the height versus body mass graph, right? This is really pinched up and not looking so great. So in this instance, we're going to double click on the y-axis, and we're going to reformat this a little bit so that our minimum, instead of being 0, is 60, kind of holds everything in there. So we're going to put 60, and that spreads everything out a bit more so that it's easier to look at. Okay? Now, what you're going to do with this is on your answer sheet. Let's pull that up real quick. You're looking at, does there seem to be any difference between protocols and how much heart rate increases over the length of the workout? This is a yes or no question, okay? And that'll directly pour into describing what you see, okay? So you're considering net changes in percent heart rate max. Net being not the difference between each time point, right? You're looking at the beginning of the workout and how that differs from the end of the workout, right? So if I wanted to look at the difference in net, or the net change in heart rate for the low pedal rate, which is the blue dots, right? If you hover over any data point, you will notice that the coordinates, right, are in parentheses. So this is at a 0, 0 time point, and 66 is the Y, or 66% of a heart rate max is the average for that pedal rate, right? And then we can look at the difference between 66 and 86, right? So we know for this particular pedal rate, the net change in heart rate is approximately 20%, right? So you'll look at comparisons of each of the pedal rates, or the net differences, and then say if you think there is an actual difference between protocols. Okay, before I forget, don't forget to put your chart title in. So I'm just going to put heart rate values. Okay, and then don't forget to copy and paste this into your answer sheet. All right, the last question on this particular spreadsheet is a bit up to your interpretation on whether you think the net differences are actually different from each other. Obviously, we're not doing any statistical calculations. I just want to see that you guys are looking at the graphs with a semi-critical eye, just based on observation. Okay, so make sure that you submit your completed answer sheet. Everybody will do one on their own. Okay, when you put your answers in, if you could please, what I do when I have like short answers like this is I just highlight it, and let's say I'm going to make it red, and then you just start typing your answers. Okay, type your answers in a different color. It makes it a lot easier for me when I'm grading, because it stands out, and it kind of expedites the grading process a bit more. Okay. So answers go in a different color. You'll submit that completed answer sheet either as a Word doc or a PDF. And then you'll also submit your completed Excel spreadsheet. Okay. All of this must be turned in by next Monday, which I believe is August 31st. Okay. At 11:59 p.m. Okay. No exceptions. If you turn it in at midnight, 12 o'clock on the nose, you will no longer have access to the Dropbox. Okay? Just kidding. That's a lie. That's for quizzes. You'll have access to the Dropbox a day later, up to 24 hours, but you do have a point deduction if you turn it in after the due time. Okay? Try to get as many points as you can, because that'll dock off 5%. Okay? Per syllabus rules. If you guys have questions on this activity, please shoot me an email. I would recommend going through, doing the activity with the video, answer the questions, and then when you feel comfortable, go back through with a fresh data set and try doing everything again, just to make sure you have the procedures down and that you can do it by yourself. Because ultimately, when you're being tested, you will be doing everything by yourself. Okay, but hopefully this is helpful. If you have any suggestions or things you didn't like in the video that you want to toss my way, please add those. Questions specifically related to this activity can also be posted in the discussion board on Beachboard for week 1. That has questions pertaining to the lecture content as well as the activity. Okay, good luck, you guys.